Your company is betting its future on AI. The real constraint isn't the model or the chips. It's electricity, and a waiting line most executives have never even heard of. It's called the interconnection queue. It's the line every large power project must join to reach the grid. Right now, that line is where AI ambition goes to wait. Data centers can be built in months. Getting them powered can take years. In this briefing, I'll show you why the grid, not the GPU, is becoming the real ceiling on AI. And I'll give you the questions every technology leader should ask before the next big infrastructure commitment. Let's decode the hidden system behind the AI build-out. Start with demand. AI workloads are extraordinarily power-hungry. In the United States, data centers used about 176 terawatt-hours of electricity in 2023. By 2028, that's projected to reach between 325 and 580 terawatt-hours. That's a doubling, or more in just 5 years, from a base that was already large. The International Energy Agency expects AI to drive surging data center electricity demand worldwide. Every new cluster of AI accelerators is, in effect, a new industrial power customer. A single large AI campus can request as much electricity as a small city. So the question stops being, can we get the chips, and becomes, can we get the power? Here's the part that surprises most boardrooms. You can't just plug a data center into the grid. Any large facility has to formally request a connection and wait for approval. That request enters the interconnection queue, run by grid operators and utilities. And that queue is now historically, staggeringly full. Berkeley Lab reports more than 2,000 gigawatts of power projects were waiting to connect at the end of 2025. That's more than double the entire installed capacity of the U.S. power system. Roughly 8,000 projects, generation and storage, all standing in line. And the line moves slowly. The median project built in 2025 waited more than 5 years to connect. Wait times have doubled, from under 2 years in the early 2000s to over 4 years in the last decade. Worse, most projects never make it. Of the capacity that entered queues from 2000 to 2020, only about 13% was operating by the end of 2025. Around 3/4 were withdrawn. The queue isn't just slow, it's a filter. So why is the line so long? The bottleneck isn't the data center itself. It's the wires. Connecting new load often requires new transmission and grid upgrades. And transmission is painfully slow to build. Major lines can take 7 to 11 years just to permit. Google recently warned that transmission delays are now its #1 challenge to data center expansion. Utilities have quoted connection timelines of 4 to 10 years. One reportedly said 12 years just to study the request. Even equipment and skilled trades face extended lead times as the whole industry expands at once. Then there's location. The best sites for power aren't always where companies want to build. Grid constraints are regional. Some markets are effectively full, while others still have room. Some markets, like Texas, have even introduced bring-your-own-power mandates for large loads. Now translate that into business terms. Delay is the real cost. JLL reports the average grid connection wait in primary data center markets now exceeds 4 years. And a data center's shell can be built far faster than the grid can power it. So you finish the building, and then wait, sometimes for years, to energize it. That gap, built but not powered, is stranded capital, sitting idle. Scarcity of already powered sites has pushed some colocation prices up around 20%. Goldman Sachs estimates roughly $720 billion of grid investment will be needed through 2030. So how are the biggest players responding? Effectively, by going around the queue. The first move is behind-the-meter generation, building your own power on site. Much of that is natural gas, which raises real emissions and reputational questions. The second is co-location, placing the data center right at an existing power plant. The third is grid-scale batteries and on-site fuel cells to firm up supply. And the long shot is small modular nuclear reactors, promising, but realistically 5 to 7 years away. Every one of these is a workaround for the same problem. The grid can't connect them fast enough. So what should you actually do? Here are the questions every technology leader should ask. First, ask for the energization date, not the construction date. Second, require the interconnection status in writing. Which queue, what position, what study phase. Third, treat multi-year delay as the base case, not the risk case. Fourth, diversify your power strategy. Location, on-site generation, and contracted capacity. Fifth, stage your commitments so you're not paying for capacity you can't yet energize. Regulators are trying to help. A reform called FERC Order 2023 is reshaping the queue toward a first-ready, first-served model. But that will take years to fully bite. The constraint is real today. The lesson is simple. In the AI era, power is the platform and the queue is the roadmap. If your AI strategy doesn't have a power strategy, it doesn't have a timeline. I'll see you in the next briefing.